So I wanted to talk about good evening, guys. So I wanted to talk about the role of friction when we are dealing with rotation. Now, I will tell you the role, or we will discuss the role in two different ways. So the first is more detailed, more thorough. Second is sort of like a shortcut that you can use. So let's say that you have an object and let's say that this is a cylinder and there is an external force acting on it, like so. And we wish to figure out what is the direction, later on magnitude of the friction acting between the cylinder and the surface. So the way to do this is number one, you forget about friction. Forget the fact that friction exists for the moment, just for analysis. Number two, draw the translation and rotation free body diagrams and find the acceleration, net acceleration of the point in contact with fluid. You could also find is also applicable for velocity. Okay. So, if I talk only about the translation of this object, and there is no friction, remember, we have forgotten about friction, then F must be equal to MA, and this implies that A must be equal to F by M. So the acceleration of this point due to translation is F by M due to translation. And then if we talk about the rotation of the object, then we'll say that torque is equal to Fr is equal to I alpha is equal to Mr square by 2 alpha. And therefore, R alpha is equal to, that was the value check. R alpha is equal to 2F by M. R alpha is equal to 2F by M. So the acceleration of this point due to rotation is 2F by M. And therefore the net acceleration, therefore the net acceleration will be 2F by M minus F by M is equal to F by M. Actually, you don't need the magnitude. You don't need the magnitude of this. You only need the direction. You only need the fact that the net acceleration is opposite to the applied force, opposite to the blue vector. And then you can say that friction opposite A net. So since A net is in the backward direction, we will find that friction is in the forward direction. Very weird.
सर बट फ्रिक्शन तो मोशन को रेजिस्ट करता है, तो इस केस में मोशन तो आगे हो रहा है ना।
हाँ, कितना बोला था ना, ये वाला स्टेटमेंट अपने दिमाग से निकाल देना। फ्रिक्शन मोशन को रेजिस्ट करता है। This is a very, very unnecessarily simple and without any content to tackle complicated problem statement. Friction opposes motion.
Yes.
Friction is just too complicated to be labeled friction opposite. पूरा पढ़ाया तो था। तो अगर सर्कुलर मोशन होएगा तब क्या बोलेगा फिर?
सर अगर उसी पॉइंट हो रहा था सर्कुलर मोशन तो फिर मैं बोलता जैसे आपने ब्लैक बनाया वैसे ही रहेगा।
सर्कुलर मोशन अगर किसी ऑब्जेक्ट का हो रहा है हॉरिजॉन्टल सरफेस पे तो कांस्टेंट स्पीड से, तो वी कैन से दैट फ्रिक्शन इज टुवर्ड्स द सेंटर। याद है ना ये सब पढ़ाया था, कार मूव कर रही है और हॉरिजॉन्टल सरफेस।
यस सर।
So you cannot please get rid of this from your mind. It is not as simple as friction opposes motion. If you want a really simplistic statement, I'll tell you it is friction opposes relative motion. So if friction opposes relative motion contains everything you need to know about friction, then this tells me that if I were to pull the cylinder with a force F as shown, then the bottommost point would be accelerated backwards. That is the key. That is what you have to really understand. And if the bottommost point would have been accelerated backwards, then the direction of friction, which must oppose relative motion, has to be forward. So this is the way that you should find the direction of this is exhaustive. This is very, very accurate. However, I do realize that while solving a problem, it might not be practical to do all this. So there is a shortcut, and the shortcut is that I'll change the slide. Let's take a screenshot. I will change the slide. Please take a screenshot. Oh, yeah. Third point. Friction will be opposite to the direction of net acceleration of the point of contact. Okay, now I want to tell you a shortcut, but again, please remember that this shortcut is not exhaustive. I will tell you when to use it, when not to use it. So, if I repeat the question, there is a object, cylinder, and there is a force F applied as shown to the topmost point of the cylinder. In this case, we want to find the friction here. Okay, so the way to do this is to draw a free body diagram of the object. So what are the forces acting on it? Well, you don't really have to draw, you can just think. If it is complicated, then you'll have to draw, of course. So without drawing friction, I will draw the free body diagram. So this is FBD without friction. Now this FBD, when you have drawn the FBD, there will be two possibilities. Okay, and the two possibilities will be that when you draw the FBD without friction, there is no torque on the system. That means all forces are, when extended, passing through the origin, or in this case, the center of mass, or there will be a torque. Okay? So there are only two possibilities when you draw the free body diagram. Either there is a torque or there is no torque. If there is no torque, then this implies that only the translation will occur. The object will translate. Yeah? And in this case, friction is opposite to the translation. Okay. And if there is torque, you find that there is torque, then you can directly say that friction will oppose torque. Now, I have to be very careful with the statement friction will oppose torque. I will tell you the limitations of this statement, but first let me show you how this works. So if you look at the diagram above, then about the center of mass, there are two choices. Either there is torque or there is no torque. In this case, what is the choice? This case, what is the choice? Is there a torque on the system? Is there a torque on the cylinder or not?
Yes, sir.
Yes, sir, due to force.
By the force.
Friction will oppose this torque. Friction will oppose this torque. Friction will not care about the force. Friction will oppose the torque. But there is a limitation to this. There is a limitation to this. The limitation is actually here. The limitation is actually here in the comprehensive method. The limitation is that as long as this acceleration due to translation is, acceleration due to rotation is greater than the acceleration due to translation of the lowermost point. As long as that happens, we can safely say that friction will oppose torque. Okay? Friction will oppose torque. But the moment this does not happen, then all this shortcut, ये सब breakdown हो जाए, ये सब काम नहीं करेगा. So before I show you, ये काम कब नहीं करेगा और उस केस में क्या करना है, let me just discuss one small thing. So if we have a cylinder on an inclined plane, where is friction? What is the direction of friction? Use the shortcut. Use the shortcut. If we have cylinder on an inclined plane, where is the friction?
Sir, up the incline.
So if you draw, yes, if you draw the FBD of this object, you will find that there is mg acting on it, and there is a normal reaction acting on it. Okay. And there is nothing else, because I'm saying that you have to draw the FBD without friction. Now, in this case, about this point, remember, when we draw the FBD without friction, do we end up at a situation of no torque, or is there torque?
No torque.
No torque.
No torque.
No torque.
No torque. So no torque का मतलब ये हुआ that now this object we can sort of get rid of the fact that this is a rigid body, and if there is no torque, that means there will be no rotation. That means only translation will occur. That means you don't have to think of it as a cylinder. You can think of it as a box or a point, whatever however you want to visualize, you can. The fact is that irrespective of your visualization, whatever path you follow, you will find that this object will translate. This object will translate, and then you have to figure out where it will translate. Well, if I were to keep a cylinder on this inclined plane without friction, then the cylinder would simply slide down. It would not roll down, it will slide down, and therefore the direction of friction must be, opposite to translation, must be in this direction. Okay? अब जब एक बार हमने फ्रिक्शन का डायरेक्शन तय कर लिया और हमने फ्रिक्शन को अपने एफबीडी पे बना दिया, then of course we have to take it from the top, I mean, because now we do have friction, and now we do have torque, now we do have other forces acting on it. So this technique, this thing that I am discussing, is a technique or a way to find out the direction of friction where rolling is, where rotation and translation is involved. Okay? Like I discussed in the last class, it does not matter if you choose the other way around. The answer that you'll get will automatically come out to be negative, so you know that choose kiya hai, but it always helps. Okay. I hope this is clear. Now I want to talk about the limitations of this method. So supposing, please take a screenshot. I'll change the screen. So supposing that I give you a situation where we have a cylinder or a sphere or a ring, whatever, and the force acting on it is like this. This is a horizontal force, F, and it is acting on the cylinder at a distance of R/4 from the center. And I ask you, what is the direction of friction? So in this case, you can apply the shortcut, no doubt, but your answer will be wrong. So let me work it out using the exhaustive method. So we draw the FBD. We have mg, we have m. I've not drawn any friction. So for translation, by 4, I don't know why. So for translation, A is equal to m by m. So this point has an acceleration F by m. then for rotation, F into R by 4, this is the torque now, is equal to mr square by 2 into alpha. R cancel हो गया. R alpha now comes out to be F by 2m. So the acceleration due to rotation is F by 2m. Therefore, the net acceleration of this point. Remember, I'm not interested in the magnitude of the net. I'm only interested in the. Let me flavor for this. So this is F by 2m. So the net acceleration of this point is like this. A net is like this. And therefore, friction.
सर इस पे तो शॉर्टकट काम कर रहा है ना?
नहीं कर रहा है
सर अगर आप सेंटर से एक लाइन बनाएंगे तो और उसका परपेंडिकुलर लेंगे, क्लॉकवाइज आ रहा है तो उसका ऑपोजिट में फ्रिक्शन होगा ना?
क्लॉकवाइज टॉर्क है तो एंटी क्लॉकवाइज टॉर्क फ्रिक्शन प्रोवाइड करेगा ना. मैंने शायद पूरी तरीके से नहीं बोला क्या? जो मैंने शॉर्टकट बताया, friction will oppose the torque, मतलब friction will create a torque which will be opposite to the applied torque. In this case, the shortcut will fail. In this case, the shortcut will fail. There is another case where it will fail, and I want you to figure it out this time. Question 1. Find the direction. For big नहीं जब तक मैं बताऊंगा नहीं प्रतीक्षा वो क्या है तब तक नहीं you have to work it out.
सर लेकिन जो आप बनाए हो उसमें तो पीछे रहेगा ना, क्योंकि एक्सेलरेशन नेट आ गया.
नहीं, नेट एक्सेलरेशन निकालो, रिंग है ये.
सर मैं वो एग्जांपल की बात कर रही थी.
हाँ,
जो आपने ऊपर एग्जांपल दिया उसकी बात कर रही थी.
तो ऊपर जो एग्जांपल दिया, हाँ क्या बोल रहे हैं उसमें, क्या बोल रही है?
पीछे होगी ना उसमें फ्रिक्शन.
हाँ पीछे ही तो बनाया ना, एफ देखो ना, रेड एरो.
सर इसमें तो मतलब कैंसिल हो रहा है पूरा.
हाँ
फ्रिक्शन
नेट
नहीं
जीरो
होगा
हो रहा
इसमें.
है.
और अल्फा और
फ्रिक्शन
एक्सेलरेशन
नहीं होगा
सर. हाँ इसमें कैंसिल हो रहा है.
वेरी गुड, यस. तो अगर जीरो हो गया, यू शुड हैव आस्क्ड मी दिस ना. वो बड़ा है, अगर ट्रांसलेशन बड़ा है तो फ्रिक्शन उल्टा हो गया, रोटेशन वाला एक्सेलरेशन बड़ा है तो फ्रिक्शन आगे हो गया. दोनों बराबर हो गए तो क्या होगा? So in this case, although the surface will be rough, there will be no friction. So although surface is rough, there is no friction. Okay? So this is another place where the thumb rule will fail. Right? So thumb rule कब applicable होता है? When you can be absolutely sure, number one, force must be applied from the top. Number two, moment of inertia must be less than mr square. If you ring the moment of inertia, mr square होता है. इसलिए a is equal to r alpha आ रहा है. और अगर मोमेंट ऑफ इनर्शिया जो है वो ग्रेटर देन 1 रहेगा, अगर मोमेंट ऑफ इनर्शिया ग्रेटर देन 1, लुक एट द इक्वेशन दैट आई हैव रिटन ऑन द राइट हैंड साइड हियर ऑन द स्लाइड. अगर मोमेंट ऑफ इनर्शिया ग्रेटर देन 1 रहेगा, फोर्स तो टॉप से ही लगी है, तो एफ आर हो गया टॉप, उसकी कहानी खत्म हो गई। लेकिन अगर मोमेंट ऑफ इनर्शिया ग्रेटर देन 1 हो गया तो फिर से आर अल्फा की वैल्यू एफ बाई एम से कम हो जाएगी और आपका रूल ये फेल हो जाएगा। नाउ यू मस्ट आस्क, नाउ दिस मस्ट बी देयर इन योर हेड, तो ये रूल फिर आया क्यों है जब ये फेल हो रहा है? क्योंकि हम केमिस्ट्री तो पढ़ नहीं रहे हैं, यहाँ पे सारे रूल फेल हो जाते हैं, एक्सेप्शन आ जाता है। The reason why I have, so first of all, I told you the comprehensive way, which never fails. The reason why I have showed you the rule is because generally you will be dealing only with spheres and cylinders. Very rarely do you come across objects which are not spheres, not cylinders. And if you are dealing with a sphere or a cylinder and it is rolling on a horizontal or an inclined surface, then the rule will work. 99.99% of the question, rule will work. But you must be absolutely aware कि कहाँ पे rule नहीं work. The moment you see force आड़ा तिरछा लग गया, ऊपर से नहीं लगा हुआ, the alarm bell should ring. The moment you see a ring, alarm bell should ring. The moment you see an object which has a moment of inertia greater than mass of the object into radius square, you should fall back on the original, on the comprehensive. And I just wanted to show you this, that it is also possible that friction is completely absent. Although the surface is rough, you are applying a force. Moment of inertia greater than mr square होएगा ना, अगर greater than mr square होएगा अगर, तो फिर r alpha की वैल्यू f by m से कम हो जाएगी। ट्रांसलेशन वाला f by m है, रोटेशन वाला कम हो जाएगा, तो a नेट इधर ही आ जाएगा, तो फ्रिक्शन पीछे चला जाएगा। And if you think this is too complicated for you to remember, don't worry. Don't worry. This always works. This always works. It may take you 10 more seconds, 12 more seconds. It always works. Okay, next question. no slipping का मतलब हुआ that there is friction, right? Then moment of inertia क्या होता है? Solid sphere. यूज किया उसको कि नहीं किया? चलो देखो मैं बता रहा हूँ. So of all the questions we have been doing until now, okay, now there is a additional factor of friction. अभी तक we were not dealing with friction, and the discussion that we had up till now was specifically just to find out the direction of friction. Although it does not matter, you can take friction anywhere. Of course, it must be parallel to the surface. ऐसा नहीं कि friction ऊपर ले सकते हैं. Must be parallel to the surface. You can take friction anywhere, any of the possible directions of friction, and you will get the answer. No problems. However, however, you need to be careful. And this is absolutely natural, normal what you are doing. Where do you need to be careful? The last half-hour discussion that we have had is merely for finding the direction of friction. Once you have found the direction of friction, then that's it. Okay, then that's it. Now you have to start afresh. The question must be started from zero now with the knowledge of the direction of friction. So in this case, I will quickly go through the motions. ये अपना mg एक्ट कर रहा है यहाँ पे और ये एक नॉर्मल रिएक्शन एक्ट कर रहा है यहाँ पे. ये हुआ कि there is no torque. If there is no torque, then this means that this will translate, and therefore friction must be opposite to translation. Therefore, this must be. The whole exercise of forgetting about friction and drawing a conclusion is so that we can draw the red arrow. Once we have drawn the red arrow, now we wipe the slate clean. Once we have drawn the red arrow, once we have drawn the friction arrow on the FBT, we wipe the slate clean and we start from the beginning. We say now, for the translation of sphere, we have mg sine theta minus f is equal to. Please also notice, this is very, very important. While dealing with friction in this chapter, in the domain of rotational motion, I will always write friction as F. I will take it as a variable. I don't know its value. Unless the word, you remember, this is the same phrase that was used in translational mechanics as well. Unless you come across the word phrase just slipping, just does not slip. It is just going to slip. It just slips. Unless this phrase or a similar meaning phrase comes along, you will never ever take the value of friction to be mu n. Okay? Because this is the thing to understand. The friction between a rolling object, a rolling rigid body and a surface is almost always static friction. इसीलिए मैं उसको स्मॉल एफ लेके चल रहा हूँ. स्मॉल एफ की वैल्यू वेरी कर सकती है डिपेंडिंग ऑन सर्कमस्टेंस. अगर स्लिपिंग शुरू हो गई, अगर स्लिपिंग शुरू हो गई, इसका मतलब ये होएगा दैट नाउ the relative velocity of the bottom of the rigid body does not have the same velocity as that of the surface, right? तो हम उसको हिंदी में बोलेंगे कि वो घिस रहा है उसको. स्लिपिंग का एग्जैक्ट मीनिंग यही होता है, घिस रहा है उसको. I'm sure all of you have seen movies where the hero gets inside the car and he makes a weird face and he, or maybe it's a villain, I don't know, and then he pushes the accelerator. Pura accelerator pedal pura daba diya. And then we see a shot of the car from outside and we see that the wheels of the car are spinning furiously, but the car is hardly moving ahead. Eventually, of course, the car does accelerate and does move ahead. But in that initial couple of seconds, we see that the wheel is spinning, but the car is not moving ahead. This is slipping. Another scenario. वो हीरो है या विलेन है, कार खूब तेज चला रहे हैं और अचानक कोई सामने आ गया, ब्रेक मार दिया. और जब ब्रेक मारा तो again we are seeing an external shot where we see that the tire of the car has actually stopped rotating because the protagonist has, pumped the brakes. And since the tire has stopped rotating, we can see that the tire is not in motion, but the whole car is in motion. आगे यार यहाँ जिसको drifting भी बोला जाता है, drift is actually a very special another thing. So this is slipping, and in both cases you will see tire marks on the road. Whenever slipping occurs, then the coefficient of friction becomes equal to the coefficient of kinetic friction. And coefficient of kinetic friction is lower than the coefficient of static friction. Therefore, we now have cars with a system called ABS, safe braking. What does ABS do? Well, the ABS will ensure that even if you suddenly jam the brakes, the wheel will not stop rotating. आपने ब्रेक को पूरी ताकत लगा के दबा दिया, of course, because of some emergency, you see, you have to stop. आपने ब्रेक को पूरी ताकत लगा के दबा दिया. एक नॉर्मल कार में इसका जो रिएक्शन होएगा, इसका जो कॉन्सिक्वेंस होएगा, वो ये होएगा कि आपकी कार के व्हील तो रोटेट करना बंद हो गए, लेकिन कार itself is going forward. And now the thing responsible for stopping you is kinetic friction. But if the wheels keep on rotating, of course, their rotation is, very, very at a very high rate. it is going down, the angular velocity is being reduced very rapidly. But since it is always rotating, the thing responsible for stopping your car is static friction. And since the value of static friction is always greater than kinetic friction, it turns out that your car will stop faster if the wheels keep on rotating. That is what they mean by ABS. They don't want your car to slip. If you don't have a car with ABS and you still want to mimic this, then you have to pump the brakes. That means you push the brake, then you leave it, then you again pump it, then you leave it, again pump it, and leave it. So please notice that I will always use F for friction. If, however, my hand is forced, नहीं, अब आप मेरे को बताइए कि इस कंडीशन में जस्ट स्लिपिंग होएगा कि नहीं, या जस्ट स्लिपिंग नहीं होएगा. ये वर्ड जस्ट स्लिपिंग आ गया, ये फ्रेज जस्ट स्लिपिंग या इसका कुछ इक्विवेलेंट आ गया, देन आई विल टेक फ्रिक्शन एज नॉर्मली जो हम लेते हैं म्यू एन की वैल्यू लेते हैं. अदरवाइज आई विल for the rotation of the sphere, Fr is equal to I alpha is equal to 2 by 5 mr square. And then constraint. Due to translation, the acceleration is like this, A, because center of mass का acceleration है. But rotation is anti-clockwise because you see only torque is applied by friction. So therefore rotation must be anti-clockwise and therefore this must be R alpha. So A net we can say is either R alpha minus A in this direction, R alpha is greater than, or we can say A net is A minus R alpha in this direction. But constraint tells me that the acceleration of this point and the acceleration of this point must be same. So therefore I have A minus R alpha, which is the A net of point on sphere, must be equal to 0, which is A net of point on wedge. So mg sine theta minus F is equal to ma. F is equal to 2 by 5 ma. Mg sine theta is equal to 7 by 5 ma. A is equal to 5g sine theta. Okay. Added का क्या हुआ मतलब? ये क्या लिखा है मैंने? ये क्या लिखा है? ये क्या है? ये क्या है? कहाँ पे फ्रिक्शन का क्या हुआ? Oh, भाई यार देख. Okay. चलो, I will change the slide now. I'll give you another question. So a cylinder is pushed using a plank as if net horizontal force on plank is F and all surfaces have friction or roughness. Find acceleration and magnitude of friction at all surfaces of cylinder. Yeah, so you have to find the acceleration of the cylinder and you have to find the value of friction force at all surfaces of the cylinder. Please do it slowly and accurately.
So,
सर सिलेंडर हॉलो है कि
अरे जब मैं सिलेंडर बोलता हूँ तो सॉलिड है.
ओके सर
सर ये सिलेंडर बैकवर्ड डायरेक्शन में जाएगा ना?
आप बताओ, you tell me. आपके पास you have your pen, right? You keep your pen on the table and you keep your hand flat, keeping it like the plank on the pen and try to push your hand forward and see what happens to the pen. गलत आंसर दिया मेरे को. नहीं, मेरे ख्याल से कुछ एम और एम के उसमें आना चाहिए, ये ऐसा तो नहीं आया।
सर इक्वेशंस बन गए, सॉल्व ही नहीं हो रहा।
नहीं नहीं, ऐसा नहीं है, इजी है भाई। एक इक्वेशन बनेगी, दिस इज हिंट फॉर एवरीवन, एक इक्वेशन बनेगी फॉर ट्रांसलेशन ऑफ प्लैंक, एक इक्वेशन बनेगी फॉर ट्रांसलेशन ऑफ सिलेंडर, एक इक्वेशन बनेगी फॉर रोटेशन ऑफ सिलेंडर, और दो कंस्ट्रेंट की इक्वेशन बनेगी। हाँ बिल्कुल सही, जो कंस्ट्रेंट की इक्वेशन होगी स्ट्रेट फॉरवर्ड होगी। बहुत बढ़िया तरह, यस। एक फैक्टर मिसिंग है तरफ तेरे आंसर में, डिनोमिनेटर में एक फैक्टर मिसिंग, देखना फिर से try कर। ये आईआईटी का क्वेश्चन है, सो दिस cannot be that the equations will come out to be unsolvable.
है मतलब 5 इक्वेशन है, वेरिएबल्स भी उतने ही है, लेकिन टाइम लग रहा था।
करो 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 आराम से करो।
सर आपको एक्सेलरेशन भेजा।
क्या? हाँ शिवेन बिल्कुल सही। नहीं शिवेन कुछ गड़बड़ लग रहा है, क्या मुझे गड़बड़ लग रहा है? पार्स का सही, कैपिटल एफ होना चाहिए, पार्स स्मॉल एफ।
हाँ सर, वो थोड़ा शिफ्ट नहीं दबा।
So I can draw the FPT for the plank. I think this should give you a lot of help. F F1. F1 is the friction force applied on the plank by the top surface of the cylinder. So for the cylinder, I can write F minus F1 is equal to MA1. एक फैक्टर चेक कर दो भाई, आपकी तो सही लग रहा है क्या? हाँ फ्रिक्शन बता रहा है ना, हाँ यस। ये फ्रिक्शन कहाँ है पार्ट, वेयर इज दिस?
सर एट बॉटम मतलब जहाँ पे सिलेंडर फ्लोर से मिल रहा है.
Okay, chalo. So let me solve this. Believe me, there are so many more questions. Abhi, this is the tip of the iceberg that we have started. Okay, and इसके बाद से please remind me we have to do. क्या बोला था परीक्षा उसने? Rotational kinematics करना है. फिर उसके बाद आगे बढ़ना. नहीं, गलत आंसर. So कैसा आंसर दिया है? So I can be absolutely sure. I can be absolutely sure about this guy. It is without a doubt. Why? Because if on the plank the friction was in forward direction, then I would end up violating the law of conservation of energy. Right? I would not have to apply any force. The plank would the plank would accelerate with bigger acceleration as compared to the force required. So if the friction applied by the top surface of the cylinder is in the backward direction, that means that the friction applied by the plank on the top surface of the cylinder must be less. Now, if I want to find the friction on the bottom surface of the cylinder, all I do is I draw the FBD, okay, and I realize that there is torque on the cylinder. Please remember that यहाँ पे जो मैंने लिखा था, forget about friction. So this is not about universal friction. Forget about friction everywhere. ऐसा नहीं. Forget about friction on relevant surfaces. That means जिस surface पे आप निकालना चाह रहे हो friction का direction, उस पे you forget about friction. So, is there a torque on the cylinder in the absence of friction at the bottom surface? Yes, there is. What is the direction of this torque? Clockwise. So the friction at the bottom surface will apply an anti-clockwise torque. Therefore, it must be like this. So the next force on the FBD is F2. Then we have mg. We have N. So now I can begin solving for translation of cylinder.
सर ऊपर प्लैंक से भी एक नीचे नॉर्मल जाएगा.
हाँ, एक नॉर्मल. So for translation of cylinder, we get F1 plus F2 is equal to capital M. For rotation of cylinder, we get F1R minus F2R is equal to mr square by 2 into alpha. Now, constraint at bottom surface. Okay, let's see what is the constraint at the bottom surface. So I have assumed that the acceleration of the object is a2. I have also assumed that the angular acceleration is alpha. Okay, और ये कहाँ से आ रहा है? यहाँ से आ रहा है. इक्वेशन से मैच करना चाहिए. यहाँ पे मैं ड्रॉ कर रहा हूँ. मैंने यहाँ लिखा है F1R minus F2R. So I'm assuming that F1R is greater than F2R. Therefore, I have assumed that clockwise torque is greater than anti-clockwise torque. Therefore, the rotation must be clockwise. So, at the bottom surface, what do I have? Well, at the bottom surface, I have A2 due to acceleration, due to translation, R alpha due to rotation. So the net of this point must be A2 minus R alpha, must be the same as the acceleration of this point. So we get A2 minus R alpha is equal to 0. Then constraint at top surface. So acceleration due to translation, A2. Acceleration due to rotation, R alpha. So the acceleration of this point is A2 plus R alpha, and the acceleration of this point is A1. Right? Remember
A1.
that दोनों का acceleration point of contact का दोनों bodies में point of contact का acceleration same होना चाहिए. So we get A2 plus R alpha is equal to A1. But this gives me A2 is equal to R alpha. So this gives me A1 is equal to 2A. Okay. Very good. Now let's solve. So we have capital F minus F1 is equal to small m into A1, but I don't want to write A1. I will write 2A2. And then I write F1 plus F2 is equal to capital M. Okay. And then I write F1 minus F2 is equal to M R by 2 into alpha, and alpha I'm going to write as A2 by R. So this will be. I will multiply this equation by 2 and I will add all the three equations. 2F1, F1, F1, F2, F2.
सर मैं इक्वेशन से घूमता जा रहा था एक से दूसरे में.
थोड़ा केयरफुल रहना है. A2 4M plus 3M by 2. So we get A2 is equal to 4F upon 8M plus 3M. Notice that the result is very similar to the result we got in the question of the last class. In fact, जब भी ऐसे सिलेंडर के क्वेश्चन आएंगे, the result almost the same. Now that you have A2, of course you have A1 as well. And if you have A1, you have F1 and F2 as well. So this was a 10-mark question in IIT. I hope the algorithm of solving is getting clearer. There are some things which I take the long way of doing because I don't want to get confused in any other question. But if you look at this, if you see that the bottom surface is stationary, then it is pretty much guaranteed that A cum of the rigid body will be equal to R alpha. And the acceleration of the topmost point, because of the fact that A cum is equal to R alpha, will be twice the acceleration of the center of mass. तो ये जो मैंने लिखा है constraint at bottom, constraint at top, If everything is normal, you can choose to forgo this and you can simply write A2 is equal to R alpha and A1 is equal to 2. But if there is anything out of the ordinary, कुछ गड़बड़ हो रहा है, तो फिर then you need to do this whole thing. चलो, अब इसको उल्टा कर देते हैं. ये आया सबको समझ में? Anybody not understanding any step? Please tell me now. Anybody not understanding any step? Please take a screenshot. Anybody having difficulty in translation of Planck, translation of cylinder, rotation of cylinder, constraints? Of course, before you do any of this, you have to work out the direction of friction. You don't need to work out the direction. You could have chosen F1 आगे, F2 पीछे, सब choose भी कर सकते थे, तब भी आंसर बिल्कुल वही आएगा. But I find it better to know the direction of friction and then proceed. You can choose to forgo. You can choose to forgo. So next question, then try. Everybody should get this right. Next question. Find acceleration of Planck if the floor is smooth and no slipping between the hollow sphere and the Planck numbers. आराम से करो. Take your time. You must be clear in your mind what you are doing. इसका आंसर मुझे याद नहीं।
सर इसमें 4 इक्वेशंस आएंगे ना?
हाँ, translation of line, translation of sphere, rotation of sphere, constraint. नहीं 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 नहीं, देखो इसके ऊपर सेम एज बिफोर, अगर मैंने इसके ऊपर ये लगाया है, वर्चुअली गारंटीड है कि इसके ऊपर फ्रिक्शन पीछे आने वाला है। और अगर फ्रिक्शन पीछे आया प्लैंक के ऊपर, तो इसके ऊपर फ्रिक्शन आगे आने वाला है। I don't need to write F1 because there is only one friction. देखो भाई, ये सबको क्लियर है? जस्ट क्लियर टू एवरीवन।
सर अगर हम हॉलो स्फीयर का एफबीडी बनाए बिना फ्रिक्शन के तो टॉर्क नहीं होगा।
हाँ, फिर आगे बताओ।
तो ट्रांसलेशन के अपोजिट
तो ट्रांसलेशन ही
पीछे
कहाँ
की
होगा
साइड।
अगर 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 फ्रिक्शन नहीं होगा? मैंने बोला था ना, वो शॉर्टकट डज नॉट वर्क एवरीवेयर। इस केस में व्हाट यू हैव टू सी इज कि अगर फ्रिक्शन नहीं है हॉलो स्फीयर और प्लैंक के बीच में, और अगर अगर ऐसा है, दिस इज सो, due to the application of the external force capital F, the plank is going to move towards the right, and therefore the relative motion of the plank with respect to the hollow sphere is to the right. Therefore the friction on the hollow sphere must also be to the right. Relative motion oppose करेगा, relative motion oppose करेगा। कौन अपोज कर रहा है? किसका रिलेटिव मोशन अपोज कर रहा है? वेल, स्फीयर प्लैंक के मोशन को अपोज करेगा और प्लैंक स्फीयर के रिलेटिव मोशन को अपोज करेगा। तो अगर हम प्लैंक पे बैठे हैं तो स्फीयर हमें कहाँ जाता दिखाई देगा अगर फ्रिक्शन नहीं है? अगर फ्रिक्शन नहीं है और हम प्लैंक पे बैठे हैं तो हमें स्फीयर कहाँ जाता हुआ दिखाई देगा? वेयर विल यू सी? What will be the direction of motion of the sphere? It will be back. Therefore, friction on the sphere must be forward. And if you are sitting on the sphere, then where is the plank going? If you are sitting on the sphere, there is no friction. Where is the plank going? Plank is going forward. So the friction on the plank must be backward. Either way you look at friction उस पे आ गया है, and then it's actually very easy. Translation of Planck F minus F is equal to ma1. Translation of sphere F is equal to ma2. The rotation of sphere, please notice, this is a very distinct possibility that you will face. And that possibility is that the same thing is responsible for translation and the same thing is responsible for alpha. Now, acceleration due to translation तो ये रहा a2, ये पॉइंट का एक्सेलरेशन हो जाएगा a2 due to translation, और fr is equal to I alpha है, ये हो गया इसका रोटेशन एंटी क्लॉकवाइज, इसका मतलब कि r alpha ये पॉइंट का एक्सेलरेशन भी हो गया, तो ये पॉइंट का नेट एक्सेलरेशन हो गया a2 plus r alpha, और ये पॉइंट का नेट एक्सेलरेशन हो गया a1. So from the constraints, हाँ सही है, a1 is equal to a2 plus प्लैंक ऊपर से नीचे आया, सारे रूल्स गए, खत्म, कोई शॉर्टकट नहीं काम करता. तो अगर आप, नॉर्मली आई हैव सीन स्टूडेंट्स डूइंग, अगर आपने ये रट लिया, अच्छा ये करने की तो जरूरत ही नहीं है, तो ये करने की जरूरत ही नहीं है, a इज इक्वल टू आर अल्फा तो होता ही है मेरे को मालूम है, या ये करने की जरूरत ही नहीं है, acceleration of the top point is actually double that of bottom point, double that of center. You can, of course, you can ratify this, but the moment I give you a question, यहाँ पे उल्टा सीधा मैंने कुछ किया, सब गायब हो गया. But if you look at the solution, if you look at what I have done exactly what I did in the last question, and I have done exactly what I did in the question before, and in the questions that I keep on giving, I will be doing exactly the same thing, and that is what I want you to develop. Okay. I hope now you'll be able to solve this. हो जाएगा ना ये?
Yes, sir.
Sure. So I'll stop here. If you have any doubts, feel free to call me, message me, text me. I will clarify. Sure. Okay. Chalo guys, bye bye. See you in the next class.